piecewise functions, you still have to solve the integrals. So remember the formulas are a(n) equals 1 over L, integration from negative L to L of f of x, cosine n pi over Lx dx. And Bn is the same thing, but you integrate against a sine function. So when you're being asked for the Fourier series, you're still just trying to do these two integrals, actually three integrals, because we have to calculate a0 separately. But even before you begin calculating the integrals, you have this following question. What should L be? What do you think the L should be?
4.
Why do you say 4? Because this function is defined from negative 4 to 4. Right? Now, if you want to know what the shape is, it's like y equals to x, but the right side is not valid. It's only valid for negative 4 and 0. And then 0 to 4 is 2. So something like this. Okay? It's actually missing the value at 0. It doesn't have a value. Also, it doesn't have value at the endpoints. And you can still find the integrals no problem, because whatever value you have at these points, a single value doesn't influence the area under the curve. So it's okay even if you don't have all the values. You might have a few points that's missing. That doesn't prohibit you from having the integrals. Okay, so for this function, we have to do the a0 first. So it's always the same format. Find a0 first, which is, we decided that L is 4, so it's 1 over 4, negative 4 to 4 of the function of f dx. But because f of x is defined piecewise, you can't write the formula unless you split the integral from 0 to 4 plus an integral from from negative 4 to 0, and then plus an integral from 0 to 4. Then you know what to integrate. From negative 4 to 0, the function value is x, so you put x there. From 0 to 4, the function value is 2, so you put 2 there. And by the way, I didn't put any cosine there because when n is 0, cosine of 0 is 1, so that doesn't appear. Now the biggest annoyance when you handle piecewise defined functions is that you can no longer make use of the even and oddness. Because, see, this x is an odd function, right? And before, when we had an odd function, we could just simply say, oh, that's 0 because you're integrating on a symmetric domain. That's not true anymore because you're trying to integrate from negative 4 and 0. See, you were able to say the odd function integrated from negative 4 to 4 is 0 because odd functions have the property that if one side goes up, the other side goes down, so that when they integrate, they cancel. That's no longer true because you see this, if you're only integrating from here to there, it's all negative. Can't be 0, right? Only when you integrate this function from negative 4 to 4, these two sides are going to cancel, but you don't have the right side anymore. So that's why it's really annoying, but you still have to do the calculation. So x, when you integrate, is 1/2 x squared, and you have to plug in 0 and negative 4, plus you integrate 2, you get 2x, and you have to plug in 4 and 0. And when you plug in 0, 0, when you plug in negative 4, that's positive 16. Divide by 2, that's 8. But you're subtracting this value, right? So you have to subtract So that gives you negative 8. And then 4 times x. Oh, plus 8, so it's 0. Okay. Oh, I just realized something. My graph is kind of off. 2, if this is 4, 2 should be somewhere here. So that what happens is that even though this is not an odd function, at least the integral of these two will give you 0 because this is 8 and that's also 8. So these two add up to 0. Okay, now let's move on to an. Again, in the same manner, we have to split the integral from negative 4 to 0 and 0 to 4. Now, what goes in here? Well, from negative 4 to 0, the function is x. And then the formula says you have to multiply x. You have to multiply x and then cosine. So we multiply the cosine of n pi over 4. We determined that L is 4, so I put n pi over 4x dx. That's what you have to integrate. Plus, then from 0 to 4, the function is 2. Again, you multiply cosine n pi over 4x dx. And then you have to do the tabular integration separately. So plus minus d integral x differentiates to 1, 1 differentiates to 0. Then you put cosine n pi over 4x. This integrates to 4 over n pi. Remember, always the coefficient of x has to be taken out as a reciprocal. So the reciprocal of n pi over 4 is 4 over n pi. Cosine integrates to positive sign. And then you integrate this again, you get negative 16 over n squared pi squared, because another 4 over n pi comes out, so you get 4 times 4 is 16. You get n squared pi squared. And then you put cosine n pi over 4x. And then you put plus, minus, plus. So what happens? This integral will be 1/4 of
Isn't it 1/2 negative 4 squared positive 8? Because negative 4 squared is positive 16.
Oh, it's positive 16, but then you're subtracting, it's this minus this, right?
Yeah. Oh, yeah.
So you're subtracting, so that's why it's negative 8. Okay. All right. So for here, it's 4x over n pi sine n pi over 4x. And then plus 16 over n squared pi squared cosine n pi over 4x. And then for this one, you have to plug in 0 and negative 4. Okay, but this other one, that's easier because there's no need for tabular integration. You just have to integrate cosine, which is sine. So what do you get? It's 2 times 4 over n pi sine n pi over 4x. And then you have to plug in 4 and then 0. And then when you plug in 0, you get sine of 0 is 0, so that goes away. When you plug in 0 here, you get, what do you get? Cosine of 0 is what? 1. Right? So you get 16 over n squared pi squared. Minus, then you have to plug in negative 4. Now if you plug in negative 4, you get sine of n pi over 4 times negative 4. What's that? It will be sine of negative n pi. But then remember that sine's an odd function, right? So what happens with this minus? Being odd means you can bring it outside, right? So what's that? 0. Okay. So that's going to create 0. How about plugging in negative 4 here? What if this was cosine? If you plug in negative 4 here, you get this, and these cancel, and you get cosine of negative n pi. Now, what happens to this minus? It goes away. Why? Because cosine is a, it's an even function. Even functions consume the minus, so you get cosine of n pi, which is negative 1 to the nth power. Okay? So that means when you plug in negative 4, it gives you negative 1 to the nth power. And since it's this plugged in minus this plugged in, so you have to subtract them. That's what you get in the first part. On the other hand, when you plug in 4, you get sine n pi, that's 0. When you plug in 0, that's 0. So that's it. You don't get anything from the second part. Okay? You only get this as your answer. And once you divide by 4, this is 4 over n squared pi squared, 1 minus negative 1 to the nth power. Okay, so what I'm doing is I'm factoring out the 16 over n squared pi squared, and if you divide by 4, 16 divided by 4 is 4, so that's what you get as your AN. Is that good? Now let's try to do the BN. Same idea. Bn would be 1/4 of integral from negative 4 to 0 of x sine n pi over 4 x dx plus 0 to 4 of 2 sine n pi over 4 x dx. And this one requires plus minus d integral x differentiates to 1, 1 differentiates to 0. You put sine n pi over 4x. Integrating that gives you 4 over n pi sine n pi over 4x. No, sorry, this should be minus cosine, right? Integration of sine gives you negative cosine. Integrating that again, another reciprocal of n pi over 4 comes out, so you get negative 16 over n squared pi squared sine n pi over 4x. And you put plus, minus, plus. Okay. You know, by this time, you kind of realize something, that because you're plugging in 0 or negative 4 or positive 4, anytime you plug them into sine, what happens? You get 0. So when you compute the first integral, the only non-zero term will be given by this one. You agree? When and even more, when you plug in 0, this will give you 0. So the only time that's going to give you a non-zero term would be when you plug in negative 4 into here. So you're going to get negative 4. Actually, okay, let me just write everything down because it might be too confusing if I skip several steps. Okay, so let's just do this times this. I'm going to ignore the sine one because that's going to be giving you 0. So the only non-zero term will be provided by negative 4x over n pi cosine n pi over 4x. And for this one, you have to plug in 0 and negative 4. On the other hand, when you integrate sine, that's negative cosine, but with 4 over n pi times 2, so that's 8 over n pi cosine n pi over 4x. And for this one, you plug in 4 and 0. And the entire thing has to be multiplied by 1/2. Now let's trace what these values are. When you plug in 0, because of this x, that's 0. And then you have to subtract after plugging in negative 4. but there's a minus because you're subtracting. There's a minus when you plug this in. So negative 4 times negative 4 is positive 16, but you have to subtract it. So here's what you get. You get 1/4 positive 16 over n pi. And when negative 4 goes in here, with this, I raised it, but cosine of negative n pi is also negative 1 to the nth power. So that's what you get on the first one. Minus 8 over n pi, and then when you plug in 4, you get negative 1 to the nth power. Minus, when you plug in 0, cosine 0 is 1, so it's minus 8 over n pi. And this minus here is this minus. So what's that? That's this minus this is 8 over n pi divided by 4. That's 2 over n pi negative 1 to the nth power. Minus minus is positive 8 over n pi, but there's 1/4, so it's plus 2 over n pi. So this ends up being 2 over n pi negative 1 to the nth power plus 1. You have a question? Okay. All right, so this is the result that we get. We get A0 is 0, AN is this, and BN is this, and therefore the final answer is f of x equals to 0 over 2 plus sigma n from 1 through infinity. Since this is 0, I don't have to write anything, but I just want to stress the fact that A0, whatever you get, has to be divided by 2. Don't forget that. And then you have 4 over n squared pi squared, 1 minus negative 1 to the nth power, cosine n pi over 4x, plus, the other one is 2 over n pi, negative 1 to the nth power plus 1, sine n pi over 4x. So that's the full Fourier series.